All right, looks like we're live. Hello everyone and welcome to another Zosin session. How about that? How about that? I bet you didn't expect that shit to happen. So, today, let's do a little bit of an announcement first, right? So I'm gonna bring up my Discord server and let's make the announcement. Red Circle live on Twitch, and the topic of today's stream is essentially I raised my TempleOS. That's right. So I'm going to show the current state of my TempleOS, and after that we're going to do AoC and HolyC Day 7. Right, so I'm going to give the link to the channel, right, to the stream, twitch.tv/Tsoding. And I'm going to ping everyone who's interested in being pinged. There we go, the stream has officially started. How about that? I bet you didn't expect that the stream is going to officially start today. Right, but it in fact started nonetheless. Alrighty. So let's take a look at GitLab Tsoding AoC 2021. So for the past like 6 days, I suppose we were struggling with a pretty horrible default theme of TempleOS. So let's take a look at it for the last time. I'm gonna go to my AoC folder. Right, by the way, all of the source code you can find in the description. So here it is, here is the source code. And for anyone who's watching on Twitch, I'm gonna copy paste this thing. Alright, so let me see. So this is the default look and feel of TempleOS. We're about to witness it. There we go. So this is how it looks by default, which is kind of difficult to use, and I've been struggling to use it for like 6th day already. Today is like a 7th day, and my head always hurts after using TempleOS, like for an hour. It's just like, holy fucking shit, it's unbearable. So what I did a little bit of research, and I finally found a way to actually replace the default colors of TempleOS. Luckily it was relatively simple. So let me fetch the latest changes from a repo. And the changes that I did to the theme are available in the same repo, right? So I committed the entire configuration of my TempleOS along with the advent of code solutions. So you get basically everything for free, just like TempleOS. So and after that I'm gonna merge origin master, right? So I'm merging that. So as you can see, I added a theme.hc, and I'm going to sync the entire stuff into the temple, right? So I'm syncing all of the configuration into the temple, right? And I'm gonna run my temple one more time, and this is how it's gonna look like from now on. So isn't that pogue? I think it's pretty pogue. So essentially what I did, I took the colors of a Groovebox theme, right, Groovebox, because apparently it's very popular and it's all right. It looks all right. And I basically put them into the TempleOS. So I'm gonna copy paste this link into the chat for everyone to see, and also I'm gonna put the link to the Groovebox in the description. Groovebox theme, right? I suppose it's like it traditionally comes from Vim, right? So, and if we take a look at some of the solutions, right? So here it is. Right, so this is how the source code looks like with this theme. Is it more readable now? Right, at least it's not very bright anymore, right, and it's just like more or less pleasant to look at. So yeah, let me know in the comments below. So yeah, this is basically how it looks like, and essentially how I did that is very interesting. So let's actually go to the home folder. Right, in the home folder there's like a theme.hc. So what you can do is you can define an array of the size colors num. It's a predefined constant, basically the size of the palette of TempleOS, right? And if you basically go here, go to the definition of this thing, so basically there could be only 16 colors because the God said so. And here are the indices of the numbers, of the colors, right? So what you basically have to do, you have to replace the corresponding colors. And that's basically what I did. And then you can use the function grPaletteSet, right? And it basically sets the current palette, right? So it's just goes ahead, iterates through all of the cores and just sets all of them. So this is basically how I did that. And the only thing you need to do after that is include that file in your home sys, right? You just include it and it gets executed, you know, every time you load up TempleOS, right? So it's pretty convenient. It's pretty convenient. So now finally TempleOS is a little bit more usable. Because my head starts to hurt like when I use it for like an hour, and I still didn't get used to that for like after 6 days. So yeah, and it actually looks pretty lovely. I really like how it looks like. So anyways, let's go. Let's go ahead and try to solve the 7th day of Advent of Code in HolyC. AoC in HolyC. Oh, anyway, I'm sorry. So Advent of Code. So 7. Day 7. The Treachery of Whales. Did I pronounce that word correctly? I'm not sure how this word is actually pronounced officially by the English speakers, because I'm not the English speaker. Alright.
Treachery.
Treachery. Okay, so I'll know. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, crustaceans, zooms in to rescue. When you see program stack faults, suddenly a swarm of crabs zooms in to rescue. Anyway, each in its own tiny submarine. Who would have thought? It's too deep for them otherwise. Zooms to rescue. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. Holy fucking shit. In a single paragraph, this shit goes so fucking intense. You have a swarm of crabs, each in its own submarine, and they're preparing to blast a hole in the ocean floor with a massive underground cave system. And all of that in a single paragraph. Like, it's just, shit went down real fast. So, the crab submarines all need to be aligned before they will have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they will be aligned before the whale catches you. Maybe you can help. All need to be aligned before they will have enough power to blast a large enough hole for your submarine to get through. Okay, so align, whatever aligning mean. I'm not really sure what aligning mean in this sentence. There's one major catch. Crab submarines can only move horizontally. Okay, you quickly make a list of the horizontal positions of each crab, your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal position match while requiring them to spend as little fuel as possible. For example, consider the following horizontal position. Okay, so yeah, I see. So you can basically assume that their vertical positions are different, right? Their vertical positions are different, but their horizontal positions are also different. So yeah, all of the positions are different, and basically you need to adjust the sliders to make them go into like a same line. But where this line is going to be located, it doesn't matter, I suppose. Right. This means there is a crab with a horizontal position 16, a crab with a horizontal position 1, and so on. Each change of one step in a horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is a horizontal position 2. For this specific configuration, right? So to 2, 1 to 2. Okay. Well, I mean, you can just basically, yeah, you can kind of like brute force it to some sense. Okay. This costs a total of 37 fuel. This is the cheapest position, the possible outcome. More expensive outcomes include aligning at position 1, 41 fuel, position 3, or position 10. Remind the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Okay, so let's take a look at the puzzle input. So what are the ranges of the crabs? Okay, so these are their possible ranges, right? And it looks like it doesn't go beyond 1000, right? So, yeah. Essentially, we can build like a histogram and then go and like try each individual possible position in here and just brute force that. Should be fine. Okay, let's give it a try. So we'll see what's the maximum. I didn't want to do that actually. Okay, so let me start this stuff. So I'm gonna go in here and I need to create a new day. And I'm gonna say 07. Oh, by the way, I recently discovered that you can actually zoom in TempleOS. Did you guys know that? I think it's like Control-Alt-Z. Yeah, there we go. You can actually zoom in, but it's not particularly useful because like nothing like fits in there, and you have to constantly like scroll like this, and when you scroll it blinks like that, and it's really weird. I didn't think it's particularly usable, but it's cool that it supports that to some extent, right? So yeah. All right, so here is the new thing, and let me actually maybe quit the TempleOS because I also need to get all of the samples and also the input data and so on and so forth. So let's actually mount AoC 2021 and okay. So home AoC 07, not a directory. So it already happened. I think that already happened before, right? So if I do AoC 2021, right, there is no 7th folder, right? If I run my my virtual machine yet again, right, there is a 7th folder in here, right? So I'm gonna close the virtual machine one more time, and then I'm gonna mount one more time, and then go into mount home and AoC. And here is the 7th one. It's kind of weird, like it doesn't work for the first try or something. Maybe not everything is like synced, you know, with the hard drives and stuff like that. But every time I essentially run something or mount something, I always call sync, which supposedly like syncs all of the like cached writes and reads and stuff like that. So I'm not really sure. So that's kind of weird. Anyways, so let's go. So this is going to be something like this. I'm going to go into AoC and then 07. So I'm going to go into sample txt and let's grab the sample input. So here is the sample input. I'm going to put it in here. Then I'm going to save it, and there we go. So let's go into the input txt and grab the official input. So the input is rather large, but I think we'll be able to parse it anyway. So let's go, right? So apparently my internet went down for a second yet again, so I don't know what happened. Anyway, let's actually continue. So hopefully I synced everything, right? Hopefully I synced everything, and I should be able to have all of the input data in here, right? So let me see, here is the sample, and here is the input. All right, so that's good. And let me actually think. Right, so we're gonna probably just start iterating while we have some data, right? While the string that holds the whole content of the file is greater than 1, right? And the first thing we probably want to do is chop a single number. So I need to define that number somewhere here, right? So I have to do sv chop I64. I'm going to provide the pointer to the string, and then I'm going to assign it to the number. And then we can just print that number just to see if everything's okay, right? So it's going to be just x, and let's try to run it. So that didn't work, as you can see. That definitely did not work, and I accidentally killed my entire terminal. So let's actually go to here. So before, I actually want to maximize my Windows Max. Maximizing the window, and I'm gonna go to here and then to here, because one thing I forgot to actually chop off the comma, right? So I have to do sv chop left, sv, that will chop a single character out of that, and there we go. We have I suppose 16, 1, 2, 0, and it ends with 14. Right, let me actually confirm that that's basically the case. Yes, 16 and then ends with 14. We actually read everything correctly, more or less correctly. So, and essentially, what I want to do, maybe I want to collect all of the unique values of this stuff. Let me see. Right, if I build like a very simple code, I64, aka Beast, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic AoC in HolyC club. That's right. AoC and HolyC. So I want to have something like min and max, right? So, and min. Oh, is there something like I don't know, max int or int like I64? Oh yeah, so Terry actually defined all of this constant. This is actually very lovely. So yeah, I64 min, I64 max, and I can use all of that. So thank you Terry, very cool. So I64, so minimum has to be I64 maximum, right? So, and this thing has to be I64 minimum instead. And something is really weird. I64, I cannot type anymore. So I went into really weird mode where I can't type shit for whatever reason. Okay, so I can type it again, I64. Sometimes you just press something in TempleOS and it stops working without telling you what, and it just like assumes that you know why. Right, because that's kind of the point of TempleOS, right? You have to know what you're doing. If you don't know what you're doing, well, you better don't use this thing. All right, so here, what I'm gonna do, I'm gonna just reassign. So this is the minimum, is gonna mean I64 between minimum and x, and the same goes for the maximum mx, max I64, mx x. There we go. So, and then maybe it makes sense to remove this entire thing, and I just want to see what's the minimum value and what's the maximum. So minimum is gonna be this, right? So it's gonna be mn, and the maximum is going to be this. There we go, a max, and if I run it, minimum is 0, right? So minimum is 0. I wonder if I can use zoom feature in here. Yeah, I can. Okay, so it's actually kind of cool. It zooms in the cursor, so it makes it super easy for me to just zoom on something just to show something. This is actually very cool. Right, so the minimum value here is 0 and the maximum is 16, but this is for the sample, right? So this is for the sample. What we want to do, we want to see like also the input, right? So let's actually take a look at the input. So I'm going to run this entire thing, and then, okay. So this is going to be plus. So the maximum value is this one. So we can safely maybe put the upper boundary to 2000, I suppose. So this is one of the things we can do. We just like put upper boundary to thousands, and that's fine, at least for our data, if you know what I'm talking about. Okay. All right. So that's pretty pow. So let's define something like upper bound. Right, upper bound, and it's gonna be 2000, right? I don't know why I pressed escape in here. So, and I'm gonna actually build like a similar table as for the day 6, I think, right? Just a second. So it's gonna be I64 table, right? Upper bound, and essentially I'm gonna just build a histogram in here. So first thing we want to do, we want to memset the table. We've got a subscription. Lindra Braga, thank you so much for 13 months. Uvu, indeed. Thank you so much for 13 months of Twitch Prime subscription. Thank you. And welcome to our epic AoC in HolyC club. That's right. AoC in Holy Mother Flipping C. Anyway, so we're gonna set it. Oh shit, I started to type code in the chat instead of the TempleOS. Okay, so I'm gonna set it to 0, and then I'm gonna take size of I64, and I'm gonna multiply it by upper. You know what? I think I can just do something like size of table, right? I think it works exactly like in C, right? I remember that I already checked that, but I already forgot. Right, so if I do something like size of table is equal to this, then I can do size of table, right? And if I run it, right? So yeah, it works. Look at that. I think it works. Yeah, so it's 16,000, which is exactly the size of that thing. I need to get used to that zoom feature because it's extremely useful for explaining things. Right, so while you type in the code, it is not really that necessary to zoom in really close, but once you've done something and you show a result, it's actually very useful to just zoom in on something and just like tell the people who's watching. So it's a pretty cool operating system for like educational purposes, like explaining something, right? When you're teaching programming to somebody, I think it's kind of cool. Oh, and another interesting idea. So this operating system has an ability to draw graphics out of the box. Right, out of the box, you can just like start drawing things on the screen. And I'm constantly thinking, will I ever have an opportunity to use that in advent of code? Essentially, maybe I'll have some sort of a problem that requires like very complicated visualization, not really complicated, but continuous visualization, not just cells, but an actual like, continuous, function graphics. And could I use the ability of TempleOS to visualize things to my advantage, just to debug something? That would be kind of cool. Yeah, because you don't need to install any libraries or anything like that. The ability to draw things on the screen is part of the operating system that you can use right away, right in your code. I don't know yet how, right? So I think you have to create like a graphical context for the current task, and once you have that graphical context, you can pass it to functions that can draw things on the screen. But we can always look into one of the games, right? So it comes with a lot of games that do a lot of graphics. So at some point, if we need to draw something on the screen, we can just look into the code of the game and see how the game does that. So yeah, this is one of the things we can do. All right. Wait, TempleOS has a dark theme. It has an ability to change themes, right? It has an ability to change themes, and I just basically took a Groovebox theme and ported it to TempleOS, right? So that's what I did. It's amazing how different this looks with just a palette swap. Yeah, it's amazing. I don't know. Like, to be fair, one of the first color themes of the TempleOS, when it was not called TempleOS, was actually kind of okay. It was still bright, but it was not like acidic bright, if you know what I'm talking about. At some point, Terry made a very strange decision on the color palette, not gonna lie. Yeah. So there is a very cool video, by the way, just a second. This is the video. I can't pause it for some reason. Okay, so this is the video basically from 2010. The video from 2010 where Terry basically demos Loose Thoughts before it was renamed like several times and before his schizophrenia completely took him over. It's actually a very fascinating video. It is very interesting to listen to Terry when he was sane. It is very interesting, and this demo is actually very useful. A lot of things his demos in this video, they're still applicable to TempleOS today. So a lot of features that he shows here, there still works in TempleOS. And look, so this is the theme that was in TempleOS like back then, and it was alright. The shades of blue are actually more or less pleasant, and it play nice with like purple and white in here. But at some point, something happened, and he changed everything to completely tasteless colors, like completely like solid colors, like, you know, absolute bright, like absolute blue, absolute red, and stuff like that. So it's kind of weird, like what happened? So I'm gonna give the link to this video in the description because it's a really interesting video. Loose Thoughts demo from 2010. So, r.dots links, they are kind of links to macros, right? So basically, things that are clickable in TempleOS, they are macros that execute some code, right? So this is a macro that executes the code that lets you go higher in the hierarchy of the folders, right? And by clicking the file, you basically execute a macro that executes the like opening the file editor or something like that. So this is basically how it works. If I understand correctly. Anyways, so let's continue developing this thing. So now what I want to do is essentially I want to use X as an index in the table, and I want to increment everything in here. So after that, maybe we want to be able to dump the table and see how many of the values in the table we have, right? So let's actually define a thing called dump table, right? It's going to be something like that. And since there is a lot of values in that table, I think I'm going to skip the ones that are 0, because we're going to assume that they don't exist essentially. I64i, and for I equals 0, less than upper bound, right? So this is the upper bound plus I. And if table I is greater than 0, right? What we're going to be doing, we're going to be doing the following thing. So I'm going to essentially put 4 in here, because some of the values are going to be like 4 digits, right? And then I'm going to have like something like this in here. So this is going to be I, and then the second value is going to be table I. So there we go. Okay, so here's the min and max, and I'm not sure if I care about these things, but I'm going to keep them just in case. So this is going to be dump table, right? Dump table. And first I want to take a look at the sample, right? So if I take a look at the sample, I forgot a new line as usual. Of course, I forgot the new line. So there we go. So this is basically how it looks like. So this is like we have 3 2s, 1 14, 1 16, and this is basically like everything that we have in here, right? So that makes sense. Okay, let's take a look at the input data now. If I go back to it because I accidentally quit it. All right, so let's go here, and this is going to be 0. Oh boy. I have no idea what the hell is going on. Shift down. I don't keep shift. It's almost like some sort of a sticky... Okay, let me restart this entire thing. I don't know, the shift sort of sticked, and it keeps holding it for whatever reason. I don't know why. It's just like really weird. Just a second. Still cannot get used to it, right? And especially works really weird in the virtual machine, you know, right? Maybe if it was native, maybe it wouldn't be that bad, but I mean, it's kind of weird. Anyway, so I also have this ampersand. Let me remove that ampersand. And the thing I want you to do, I just want you to replace this one with 0 and like do something like this. There we go. So these are the things that we have. These are the values. And we don't really have that many values repeating, as you can see. So there is like a 2, right. So there's also, maximum there is only 2. Right. So, and here is an interesting thing. So sometimes there's 3. Let's actually answer like a different question. How many values bigger than 1 we have? Right, this is a very interesting question. So there's a lot of them. So there are repetitions in here, as you can see. There are some repetitions, quite a few repetitions, right? So sometimes you even have 9 of them, right? Sometimes you even have 9 of them. Okay, so that's fine. And how many of them that are bigger than 2? Right, do they even fit on the screen? Do they even fit on the screen? They do, in fact, kind of fit into like 1.5 of the screen. Okay, so there are some repetitions, but not that many of them. And all of them are fit in there fine. So I don't know if we can like use that for some data structure or something like that. Okay, so we have in here. And essentially, what we're gonna do, we can now iterate through each individual value that is greater than 0, right? And for that specific value, we can compute the amount of fuel, right? If you know the point to which you can align things, you can just go through each value, align things, and see how much fuel it takes, right? So let's actually write a function that does that. All right, so it's gonna be I64 fuel for let's actually count something like call it something like fuel count, right? And we're gonna accept alignment, right? Alignment I think it's a very big word, like let's call it align. Right, and essentially it will basically compute the amount of fuel that is needed to align to this specific point. You know what I'm talking about? Right, we're gonna have like I, and let's iterate through each individual thing in here. So this is gonna be upper bound, right, plus I, and we're only gonna care about things that are greater than 0, right? So we only care about those things greater than 0, and so we also need to have a like a result variable. So initially it's going to be 0. Just a second. Result plus, and essentially what we can do, we can align minus. So I is a position in our case, right? Align minus I, and that's how much fuel you will need. This is how much fuel you will need to just get to that point, right? But you also want to kind of like do, you know, ABS I64, right? So you want to get rid of this sign, and then since you have several of such crabs, you know, at that position, you want to multiply it by the amount of crabs. And what's interesting is that if the amount of crabs is 0, the amount you'll add to the result is going to be 0, which kind of eliminates the need for this condition at all, right? So you don't need this condition, so we can just iterate and do that. If I understood this entire thing correctly, of course. Right, so yeah, essentially, I think. Yeah, you just subtract it and you add it. Yeah, there we go. So, and then we can just return the result, right? So return the result, and this is how you fill the count. So now we can iterate through each individual value, and just for each value that is greater than 1, we can compute the fuel, right? We can compute the total fuel. So let me get rid of these things. I don't think they're needed. Right, so this is going to be I, 0, I less than upper bound. Less than upper bound, so plus I, and if table I is greater than 0, that means for this entire thing we want to count the fuel, right? So it's going to be fuel count for I, right? Fuel count for I, and we also probably want to, you know, have a result somewhere. Right, so it's going to be I64 result, right, it's going to be 0. So, and I can do min, it's actually a pretty good idea, maybe I can just do min and max, because I already have these values. Right, so it's not going to improve the, you know, the performance in any way, it's still going to be linear. But maybe it's an alright solution. Okay, so result has to be equal to minimum, right? Minimum I64 result, fuel count for I, and there we go. So in here we can say something like part 1 D, and we can just put a result in here. So that should be it, if I understand everything correctly. So let's actually go to sample and let's compute this entire thing. And it broke at the line 50, right? So it broke at the line 50 because why? I'm not quite sure, because I don't have I, of course, that's why. Right, if I try to compute that one more time, so it says 0. Very cool. Very cool. So somewhere we're multiplying by 0 or something like that. Oh, this is because I'm doing max. I see. So because so that means I have to do something like I64 max in here. We already know that we have these things. Okay, 37, right? Let me take a look. Is that the correct thing in here? 37, right? So that's basically what you have to do, 37. And what's interesting is that our brute force is square, right? So you perform thousands of iterations, and within each iteration you perform another 1,000 of iterations. So basically you perform million of iterations, which for the modern computers is okay. We'll see if for the TempleOS is also going to be okay. Okay, should be fine though. Should be fine. A little bit nervous, but probably shouldn't be. Okay, so this is our probably final answer. I wish I could just like go here. 343605. All right, so 343605 and first try. How about that? How about that? Bet you didn't expect that shit to happen. So yeah, we did it. We did it, boys and girls. We did it. That was actually pretty cool. So yeah, it was pretty straightforward. I didn't expect that. So for now, the brute force kind of worked. So let's actually do committee and maybe then even push. How about that? So let me take a look. So git status, I need to sync into the host AoC 2021. All right, so this is going to be the div. So also I want to take a look at the status. I'm going to add home AoC git status, add day 07 part 1, and I'm going to push that right into the repo. Push origin master. Alrighty. Okay. So the crabs don't seem interested in your proposed solution. Okay. Perhaps you misunderstood crab engineering. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in a horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each carb moves, moving further become more expensive, these changes the best horizontal position to align them all this becomes 5. I forgot the name of these things. Arithmetic progression? There's a formula that can compute arithmetic progression in O of 1. So essentially, if we apply the formula of arithmetic progression, we will keep the asymptotic of the current solution the same. So yeah, that's essentially, I guess that's the trick, maybe. So essentially, they're trying to trick us, right? So you have n squared, and they try to make you think that now you have to do n cube, and n cube is probably going to take some time, but maybe on the modern computers it's not going to take that much time, because it's going to be like billion iterations, and you can probably do that, right? But you can bring it down to square just by using the arithmetic progression, right? So this is one of the things you can probably do. Okay, so arithmetic progression. We'll see if we can apply that. Arithmetic progression. As each crab moves further, this changes the best horizontal position to align them all on. In example above, this becomes 5. Okay. So this cost a total of 168 fuel. This is the new cheapest possible outcome. The old element position 2 now costs 2 and 6 fuel instead. Remind the horizontal position that the crabs can align to using the least fuel possible, so they can make you an escape route. How much fuel must they spend to align in that position? Okay, so let's give it a try, my comrades. All right, so let me see. So it's gonna be AoC 2021. There we go. I'm already in the correct folder. I think I am already in the correct folder. So let me go in here, and then in here. So this is a fuel count that counts things for the part 1. So maybe we want to rename that. Slightly, maybe we want to rename that. But another thing we can probably do, we can extract a read input function. Yeah, I think this is a good idea, right? So let's actually do something like u0 read input, right? So when it essentially does, it will just read the input, right? It will open the file and shit like that. So let's actually bring this thing in here. So we're opening everything in here, then we're just iterating, and then we should not forget to free this entire stuff. Right, so, and essentially we can merge fuel count with part 1, because how we count the fuel is essentially the part itself, right? So I can probably make it make it a part of this stuff. So I'm gonna make it as I originally want it, right? So it's gonna be upper bound, right? And then if this thing is that, I don't know. So maybe I'm gonna call it fuel count 1 because I don't want to do too much refactoring. Right, so this is gonna be fuel count 1. Okay, so this is fuel count 1. And in here, right, this is gonna be read input. So we read the input and that's it. So we probably don't need that stuff in here, right? And because of that, we don't need that stuff in here. Result might be useful only for this thing, right? So it is useful only for this thing. For the read input I is not particularly useful, so I'm gonna actually bring it here, I64I, and I think that is it. I didn't see anything else in here. Let me actually try to run it, and I actually refactored everything correctly. First try, by the way, and the compiler didn't even complain about that. That's cool. Okay, so we're gonna do part 2. So I'm gonna rename this thing, and the first thing I want to do, of course, in a part 2 is read the input, right? So I'm just reading the input. Then for I0, I do I upper bound. You know what? I can copy paste this entire thing. I mean, come on. The only difference between these two functions is gonna be that instead of count 1, I'm gonna be using count 2, right? So, and part 1 becomes part 2. And also, we probably want to keep this entire thing here as well. We want to predefine these variables, right? So if I try to do that, it will say that function does not exist probably, but yeah, let's actually quickly define such function in here. I64 fuel count 2, right? So I'm using the second one, I64 align, right? So this is going to be something like this. I64I, you know what? I'm going to just return 0 for now, just to see if this entire thing compiles. Okay, so we have unused variables. Oh, I remember I saw in the source code of TempleOS, I think there was like a warn unused or unused war. Unused warn. There was a way to actually suppress that warning, but I forgot how to do that. So there was a way to do this kind of stuff. So, yesu. Okay, guys, so let's go. It's gonna be I64I, and then I'm gonna do I64 result 0. And in here, we're gonna do the following thing. I0 less than upper bound. Plus I. And what I'm thinking is, oh shit. So I have like 2 points, right? A and B. Is there any formula for arithmetic progression that can start at arbitrary positions, right? You know, I think that's it. This sum, okay. For example, consider the sum 2, 5. This sum can be found quickly by taking the numbers. All right. Derivation of our nation. So I'm not quite sure, to be fair. Because I kind of remember the way you can infer the arithmetic progression formula. No warn name of the variable. Thank you for Googling that. Thank you so much. I have no access to the Google, and thank you so much for Googling that. Okay, so let me open my Paint. Do you guys remember how you can infer the arithmetic progression formula? Because it's kind of interesting, because Gauss managed to do that when he was in 5th grade or something, right? Do you guys know that story? Do you guys know that story, how this like formula was found by Gauss? Because it's quite fascinating, I think. No. So let me actually take a look at the history. So yeah, according to the anecdote of uncertain reliability, of course, young Carl Friedrich Gauss in primary school reinvented this method to compute the sum of the integers from 1 to 100 by multiplying blah blah blah. However, regardless of the truth of the story, was not the first to discover this formula. Okay, so at least this is what our math teacher told us, is that the teacher, right, who was teaching like Gauss, and the class where the Gauss was teaching, was studying, they needed to go somewhere, right? So they needed to leave the class. So, and then the teacher came up with a problem to keep the kids busy while they're absent, right? So, and they came up with a problem. Okay, count the sum from 1 to 100. Right, and so whoever comes like first or whatever, they will get a good grade or something. So the Gauss did that like in 5 minutes. He basically reinvented the formula and just like computed sum from 1 to 100 in O of 1 essentially. And the way he did it is actually really interesting. So you can take a sequence of numbers from 1 to 100, right? And then you take the same sequence and you write it in the opposite direction, right? So you do 100, then 99, then right, 98, and then here you have 1. So now look, if you look at the corresponding pairs and you sum up these pairs, so the sum of these two pairs is going to be 101. The sum of this pair is going to be 101. The sum of this one is going to be 101, and you're going to have 100 of 101s, right? So at the end in here, you're going to be you're going to have 101. So essentially, how many of these things you have? You have 100 of 101s. So what's the sum from 1 to 100? It's basically this by divided by 2, because you summed up 2 of these sequences. Right, and because of that, this thing is going to be 50-50, right? So this is how he came up with this formula. Allegedly, it's an anecdotal story of unreliable origin and stuff like that, but that's how he came up with this thing. So, yes, I think it's a pretty interesting story, and actually it makes you kind of like easily remember how to like restore this formula, because it's a very simple approach. So, and I'm thinking, so in my case, I actually need to start not from 1, but from some arbitrary A0 up until AN. And the question is, can we come up with a similar formula for, and you know, of course, so A0 is less or equal than like AN, something like that. And essentially, to be fair, yeah, we don't need to do that. Why did I think that we need to do that? I thought we need to sum up all of the positions. So if you are at 3 and you need to go to 5, for some stupid reason, I thought that you need to do 3 plus 4 plus 5. No, you don't. Essentially, what you need to do, you need to find the distance between these things and then just like use the original formula over arithmetic progression and stuff like that. So I think I'm stupid. I think that's basically the case. Average Euler enthusiast versus average Gauss enjoyer, yeah. So I suppose that makes it even easier, because I can just like plug this entire shit into this formula, and yeah, that should be pretty easy, I think. Let's go. It's me, Gauss. What the fuck am I saying? Alright, so the first step costs 1, and if you have... So the general formula, right, the general formula is the following, right? It's n multiplied by n plus 1 divided by 2, right? So this is the general formula, and in this case, n is just equal to 100, right? If n is equal to 1, right, if n is equal to 1, you're gonna have 1. Equal to 2, you're gonna have... Okay, so that's actually pretty straightforward. Let's go ahead and code that. Let's go ahead and code that. Okay, where's my TempleOS? Okay. So I need to do ABS I64 align minus A. So, and that's basically the distance, right? So this is basically the n. So I might as well actually define that n, so it's a little bit easier for me to do this kind of stuff. The question is, if n is equal to 0, right? If n is equal to 0, the entire thing is going to be essentially 0, so I don't have to worry about it too much, which is nice. Very nice. So then I can do n multiplied by n plus 1 divided by 2. I hope that the precedence of the operators in HolyC is the same as in the regular C, but you never know, so I'm going to put parentheses here just in case. The usual precedence in C is that these kind of operators are going to be executed from left to right. So the first, this thing is going to be executed, and then the division. But again, you never know. It's better to be, you know, safe than sorry. I think this is how they say that. All right, and that gives us this value, and essentially the next thing we need to do, we probably need to multiply it by the table. Right, so this is going to be table I, and then we'll have to add it to the result. Hopefully that will kind of work. Maybe. All right, maybe. We'll see, we'll see. The winner gets T, that's for sure. So let me actually switch to the sample, right? So we're going to take a look at the sample situation. So part 1 is commented out, part 2 is running, so we read the input, then we're using fuel count 2, and in fuel count 2 we use that. So let's take a look. So 170, right? So 170, is this? No, it is not correct, of course. So, but it's kind of close. It is kind of close, so let me see. Let me see what we got. Let me see what we got. That is very, very strange. Why would it be like that? Okay, so you know what? I think I want to make a small break and refill my water super quick. And after the break, we're going to try to see where is the problem, right? So, all right. So let's actually go ahead and try to see if our formula works for the current thing in here. So Mantech44, thank you so much for the Prime subscription. Thank you, thank you, thank you. And welcome to our epic AoC in HolyC Club. That's right. So that's what we're doing. That's what it's all about. That's what we've been waiting for. That's what it's all about. Oh. So let's actually do something like this. I'm gonna take n and I'm gonna put 16 in there. Right. So this is gonna be 16. 16 to 5. Might as well, by the way, just have something like you know, 16 and 5, right? So this is what we have in here, 16 and 5. And because of that, the difference between them is going to be ABS I64, A minus B, right? So this is basically what we've got. And I can quite easily just maybe even print this entire thing. So this is going to be D, N, and if I run this stuff, as you can see, it's 11. And I think it is correct to some extent, right? So we can actually see, oh, here it is. So here is 11. I'm trying to go back and zoom. Okay, so after that, we need to see what's going to be the final thing. So I'm going to grab this thing and just like literally copy paste it, right? I'm literally copy pasting it. And I'm gonna put it in here. So the answer is gonna be maybe the fuel is gonna be equal to D, right? And we're gonna put it in here. So I copy pasted like an extra parent, so let me quickly remove that. So if I run this thing, it did not work because I forgot the semicolon, of course. I forgot the semicolon, and it's 66. Would you look at that? It is in fact 66. But now the question is, what if we swap them around? So that should be correct. So it is still 66, but what if it's the same? It is also correct, so I don't see any problems in here, so that's kind of strange. Right, so it's gonna be 15. If you have like several of them, right, 2 to 5, right, so if you have 2 to 5 and 2 to 5, right, so they consume the same amount of fuel, so that means you can just multiply them. That should be fine. So far, I didn't see any mistakes in my logic, right? At least in the logic. But maybe there are some mistakes in the execution of this entire logic, right? So maybe something there. Okay, so here is n. Okay, result is 0. So, and... Okay, so it's going to be 1. And it still says... Okay, so I need to actually run this thing. So it's 70. It is, in fact, 70. So... So we can try to maybe trace everything, right? We can try to trace everything and just see if it works correctly. Right, so I'm gonna do the following thing. So it is going to be, let's actually have something like fuel, right? And I'm going to assign the fuel to this thing, right? So n plus 1. And then I'm gonna wrap everything in here and divide by 2. So here is the fuel, right? And then I should be able to get rid of that. Here's the fuel, right? So then we have the value, right? So here is the first value, and then we have the amount of these things, right? So this is gonna be the count. You know, though, just a second. In the part 2, instead of doing this thing, right, I can probably just do something like this, right, just show me the fuel count 2 in the expected answer. So an expected answer is going to be 5, right? Show me that. All right, so it's going to be 44, 41, and in here I just forgot the semicolon, right? So, and I have a new square. Oh, it is correct. 168. So it actually computed everything correctly, right? It computed everything correctly, but it didn't. All right. Okay. All right. So did I forget to initialize something? Okay, so if I remove this kind of stuff, all right, and then I just do the result, right? And what we're doing in here, we're trying to find the minimum, and the minimum here is this one. I'm very confused. I'm very actually confused because the result here is this, right? But if you like specifically do few... Oh, I see. Because I'm an idiot. I'm ignoring the things that don't exist. So basically in this particular situation, there could be places where... Yeah. Oh my god, this one is ridiculous. So it worked for the first solution because this thing is linear. As soon as you go into the arithmetic progressions, it could be all over the place. Okay, so let's actually do it like this. So you have to simply remove this thing, and there we go. It's 168. This is very interesting. All right, so, okay. Nice. Huh, I like that. So the author actually got me. Okay, the author actually got me. But I wonder, will there a situation when it would be cheaper to go somewhere out of bounds, or maybe to the negative? We're gonna just basically assume that maybe it's not gonna force us to go out of bounds anywhere, right? So let's quickly switch to the part like the actual input, and let's just run this entire thing, and we have 96,744,904. Right, so, and I wonder if that's the actual solution in here. Maybe it is, who knows? Let's actually start typing it out. So 96, hopefully it is the correct one. If it's not, we'll have to like troubleshoot a lot of shit in here. 904. 96 744 904, and first try. How about that? Both of the parts. Easy. GG. We did it. We actually did it. All right. So let's do a committee and maybe even a pushy. How about that? Alrighty. So I usually like to do the thing where I just like uncomment both of the parts, and if I run this entire thing, here are both of the parts. Alright, so we have both of the parts. Both of the parts. Okay, it's not even that much code. And it was much more pleasant to code with this color scheme. Right, color theme, not scheme. Because holy shit, like after like an hour of using the default color scheme, like I had a huge headache. It's just like unbearable. And now it is fine, right? So how long I'm streaming already? Just a second. I'm streaming for 1 hour and it's actually fine. So I don't have any headache right now. Conclusion, AoC is too easy this year. I wouldn't say so, right? So I just happen to know about arithmetic progression. So essentially there is still trick to this problem. It's just like you have to know about arithmetic progression. If you don't know about arithmetic progressions, you essentially end up doing n cubed solution. Yeah, Yanda, thank you so much for gifting 5 tier 1 subs. Thank you. And everyone who got the subs. Welcome to our epic AoC in HolyC. Moon Postman, thank you so much for tier 1 subscription as well. So yeah, essentially, right, you have to know the trick. And who knows how many of similar problems we're gonna have in the future, right? So maybe the next problem will rely on some sort of like a Chinese reminder theorem that you just have to know. And if you don't know it, well, you're screwed, essentially, right? So maybe like in a couple of days is gonna be some sort of a theorem that you just have to know. So I don't know. So this time I just happened to know about arithmetic progression. And to be fair, arithmetic progression is like considered like a common knowledge, right? So if you went to a school, you probably know about it, but at the same time, you could have forgotten about it. Just like the fact that I know it just made it easier, but I could have, like, might as well not know that. So Chinese reminder theorem, never problem after this. Yeah, exactly. So I wouldn't say this problem is particularly easy. Right, I think there is some twist to it. And some people may find it difficult, and not because they're stupid, by the way. So, but because they just don't know or forgotten about arithmetic progression, right? But I happen to remember it, so it is what it is. Yeah, if you know something, it is easy, and if you don't know it, it's hard like hell. Like, and I really don't like this kind of problems, to be fair, right? So to solve the problem easily, you just have to know something. And unfortunately, a lot of IT companies, like software development companies, they like to give these kind of problems on coding interviews, right? And what's interesting is that the ideas that you have to know in these problems to solve those problems, they were not obvious by computer scientists that solved them at the time. Some of the problems that the coding interview gives, I don't know, computer scientists thought about them for decades before coming up with the solution. And if you don't know how to solve that problem, you are expected to actually replicate their decades of work on the spot, which is fucking unfair. It is absolutely unfair. I absolutely despise that. So, anyways. Let's just actually commit our thing and continue. Okay. So I need to do sync, and I need to sync that into the host, right? So we have that, and status git add, not GTI, git add home, git status. I'm gonna commit add day 07 part 2, right? Add day 07 part 2, and I'm gonna push that right into the repo, right? So the source code for everything I do on these streams is available in the description if you're watching on YouTube, and if you're watching live, I'm gonna copy paste this thing in the description, right? So everything is available in that repo, including my sick colors theme for TempleOS. Right, so let me actually run this entire thing. So AoC 2021. So yeah, this color theme is available in that repo, right? So basically it is located, I think it is located, AoC 2021 home theme.hc. There we go. So here's the theme, so here's the palette, and here's the code that sets the palette. So there is also a little bit of a hack in here. So you might want to include that hack as well into your configuration, but that's about it. That was the 7th day of AoC in HolyC.